Hmm. Hi guys, good afternoon. Good afternoon everyone. Welcome to my live. And yes, this is for my students only. So if you happen to open this live show and you are not my student, you are still welcome to join. Okay. What we are going to do today is I'm going to just go over our lecture on real numbers. Okay, I you have a copy of this, but let's just go over it. Alright? Hi. Ayan, nag-greet kayo sa chat box natin. So we have Rika May, Mark, we have Albert, Christine, Maui, Divina Grace, Dessa, Ariane, Carl Clinton, and Jillian. So at the moment, we are around 25. Meron din si Rika. Ayun, and Christelle. Ayan, so good afternoon to all of you. I cannot say hi to all of you, but I know that you're there. So yeah, let's just get started. So we're going to look into uh, your module. Okay, let's take a look at the set of real numbers. And by the way, guys, if you have questions, you can ask them anytime, even when I am speaking. So you can just ask any questions. I'd be able to see that in the chat room, and once I see them, I'm going to answer your questions. Okay, or question. All right, so the set of real numbers, I'm pretty sure that this is not new to all of you. The set of real numbers consists of numbers that make up the entire number system in college algebra. So it includes the rational and irrational number. So here we have the set of real numbers R, and then this would include your rational numbers Q and irrational numbers Q prime. So that's how we represent in this discussion. And of course, the rational and irrational numbers here would make up your real numbers, and each number in the set can be represented as a decimal number. So we have here our diagram below. So let's try to reduce that so we can see the entire diagram. There you go. Right. So we have here real numbers R, and that is composed of rational numbers Q and irrational numbers Q prime. And under rational numbers, we have integers represented by z and the non-integers, okay, or z prime, okay. And we can further break down integers, which is made up of whole numbers w and the negative integers, okay, which is z minus in this representation. Then we also have for whole numbers, that is, of course, it composed of the positive integers z plus and the number 0. And then your positive integers are also called your counting or natural numbers. Okay, so by looking at this diagram here, we can say that counting numbers are subsets of rational numbers. Okay, counting numbers are subsets of rational numbers. Okay, because if you can see, counting numbers is under rational numbers Q. Okay, and all the numbers below rational numbers are subset of rational numbers. Okay, so that's how you see it. And same is true with positive integers z. This is a subset of whole number w. Okay, in other words, whole numbers it consists of positive integers. That's why we say that positive integers are subsets of whole numbers W. Okay. Can we say that negative numbers are subset of non-integers? Okay, the answer there is no, because negative integers c minus here is under integers. Okay, and integers are not non-integers, obviously. Okay, so negative numbers are not subsets of non-integer, but negative numbers are subsets of the real or the rational number q or numbers q. Okay, so that's how you interpret your real number diagram here. Okay, now let's discuss them one by one. So we have here the set of positive integers z. When we were kids, it says here, we learned how to count 1, 2, 3, and so on. Okay, this counting or natural numbers form the positive integers. Okay, so when we talk about positive integers, we talk about the counting numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and so on. Okay, up to positive infinity. Okay, these are counting numbers. And then we also have the set of whole numbers, W, or the non-negative integers. Okay, this is the first extension of the set Z plus, or your positive integers, but this one includes zeros. In other words, when we talk about the whole numbers, these are your positive integers including zero. So mag-start tayo ng 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, so those are whole numbers. Okay, again, the set of positive integers, we start from 1, 2, 3, 4, 5, 6, 7, 8, and so on. But for whole numbers, that would include zeros. In other words, 0 is not included in the set of positive integers because 0 is neither positive nor negative. So it's neither positive nor negative. And then we have z, the set of integers. So for every positive integer, there exists a negative integer such that if A is a subset of C positive, then negative A is the set of negative numbers. So in other words, when we talk about the set of integers, these are the numbers that would include 0, and then the counting numbers or the set of positive integers and the set of negative integers. Okay, so think of your number line, and we're talking about integers here. So 0, 1, 2, 3 can also have negative 1, negative 2, negative 3, negative 4, and so on. So those are the set of integers. So sila yon na tinatawag natin set of integers. Okay, then we have the rational numbers. Okay, a rational number is one which can be written in the form a over b, or in the form the ratio of a and b, where a and b are integers and b is not equal to 0. So any number which can be expressed in the form a over b, okay, where b is not equal to 0, then that is a rational number, q. Okay, q is x such that x is equal to a over b, where a and b is a subset of z. Ano ba yung z natin dito? Z is the set of integers, so a subset of integers where b is not equal to 0. So in other words, the entire collection of integers and non-integers is called the set of rational numbers. So rational numbers may be represented as fraction. Could be 8 over 1, 1 half, 5 thirds, negative 2 7, negative 2 thirds, negative 10 over 25, and or decimals like 1.5 minus 3.75. But any number which can be represented as a over b such that b is not equal to 0 are your rational numbers. Okay. Now, when we talk about the set of irrational numbers, okay, it says here, in the study of geometric figures such as circles and triangles, irrational numbers were introduced such as pi, the constant ratio of the circumference of the diameter of a circle, and square root of 2, it's the length of the hypotenuse of a right triangle whose legs are 1 unit each. So the natural number e, which you see in your calculator, so if you haven't seen a calculator, or if you have with you right now, you can press e and a number will come out. Okay, it's 2.718281828 and so on. Okay, do not be amazed by that because I'm just reading this here. But if you press that in your calculator, you'll see that the value of e is this number. Okay, and square root of 2 is around 1.4142135 and so on. Okay, so these numbers are irrational numbers. Same is true with square root of 3, square root of 5, square root of 7, square root of 10, 11. Okay, those are irrational numbers. Okay, so we call them irrational numbers. Okay, these are numbers when expressed as a decimal are numbers with unique numbers that does not terminate. Okay, so 413211. So non-terminating siya and non-repeating. These are numbers that are called irrational numbers. And you can see that by extracting the square root of 2, square root of 3, square root of 5, 7, and so on. Just like what I mentioned earlier. And of course, that would include the number e, the natural number e, and pi. Okay, so you see pi is a non-repeating and non-terminating decimal number. So those are examples of irrational numbers. Okay. So I think ito yung binanggit ko kanina, no? So we can have here, it says here, there are two types of decimals, so terminating decimal and repeating decimal. So a terminating decimal is the exact representation of a fraction. That is, it is the quotient obtained by dividing the number of fraction by the denominator with a remainder of 0. Okay, so that's a terminating decimal. A repeating decimal is a representative of fraction in which a pattern of digits repeats itself indefinitely. Pure repeating decimal is repeating decimal in which all the digits are after the decimal point are being repeated. So example would be your 0.4444 and so on. Or if you divide 2 by 3, your 2/3, that's 0.66666. 1 over 3 is 0.3333 and so on. So these are these are repeating decimals. Okay. So for repeating decimal and non-terminating, these are examples of rational numbers, okay? Because it can be expressed as a ratio A over B. So for example, 2/3, 2 over 3 will give you 0.666666. This is a repeating and non-terminating number, so it's a rational number. Okay, again, rational number ang repeating and non-terminating. Irrational kapag non-repeating and non-terminating. Okay, so that is our set of real numbers. So I'm not going to talk about writing a mixed decimal as a fraction and so on anymore. Okay, so I just wanted to discuss, of course, the number, the real numbers system. Okay, now we proceed to the fundamental operations on real numbers. Do you guys have questions at this point? You probably do not have. Okay, the operations on the set of real numbers is governed by the following rules. So these are basic, of course, but let's just read them. To add two real numbers with the same sign, add their absolute values, and prefix their common sign. Okay, it's like here 2 plus 3 is 15. That's positive. And negative 8 minus plus negative 13, you just add 8 plus 13, 21. Then you use the sign which is negative. So that's negative 21. All right, so to add two real numbers with different signs, subtract the larger absolute value to the smaller value, absolute value, and prefix the sign as that of the larger absolute value. So here you will have 4 plus negative 9, so you will have 9 minus 4. But the answer there is 5. The number with the highest number with the sign, which is negative, that's the one that you're going to use. So you will have negative 5. Okay, this one is basic. To subtract, you change the sign of the subtrahend and proceed to addition using rules 1 or 2. So that's very easy. So 4 minus negative 9 is you just change that. So you will have 4 plus 9. That will give you 13. Okay. Same with the rest. So negative 7 minus 12. So that will give you negative 19. Okay. So for multiplication, you just multiply them. If they have the same sign, then that is positive. If they have, if there's two different signs in the multiplication, when multiplying two numbers, then that's negative. It's pretty basic also. Same is true with division. If you are dividing two numbers of like signs, then the quotient will always be positive. If unlike signs, the quotient is negative. Okay. So yeah. Any questions? If there is none, we proceed now to the properties of real numbers. Yeah, what we're actually doing here is we're just trying to review what's on your module because this was given to you a few weeks ago. Some of you are asking if I could at least spare a time to go over it. So that's what we are doing today. Okay. All right. So we proceed to the properties of real numbers. It's like what I said. If you guys have questions, you can just let me know by sending a message on the chat box. All right. So we have the properties of real numbers. The properties of real numbers are rules which may help us on what to do or what not to do when working with these numbers. The first one is the closure property. The sum or difference or product of two or more real numbers is also a real number. So for addition and multiplication under closure property, what this property is saying is that when you add two or more real numbers, the resulting number is a real number. Same is true with multiplications. In our example here, 10 plus 8 is equal to 18. 10 is a real number, 8 is a real number, and 18 is also a real number. So adding those two real numbers will result in a real number. Same is true with multiplication. For closure property, 6 times 7, 6 is real number, 7 is a real number, and the product is 42, which is also a real number. In symbols, if A and B are real numbers, then A plus B, A minus B, and AB are unique real numbers. Okay, in our examples, we made use of whole numbers, but you can try also with fraction like 2/3 times 1/3. It will give you 2/9. 1/3 is a real number. 2/3 is a real number. 1/9, 2/9 is a real number. So that's multiplication. Same is true when you add 1/3 plus 4/3. That will give you 5/3. Those are all real numbers. So that's what closure property. So we say therefore that the set of real numbers are closed under uh, addition and multiplication. Okay. Now we have commutative property. Commutative property is a change in the order in which two real numbers are added and multiplied. It does not change their sum or product. In other words, the order of performing the addition and multiplication operations between two real numbers does not change their sum or product. Okay, so for example, 20 plus 8 and 8 plus 20 will yield you a sum of 28. Okay, does not affect the sum. Same is true with multiplication. If you multiply 5 times 9 and 9 times 5, both will return a value of 45. Okay, and it does not affect the arrangement of multiplying and adding real numbers does not affect the sum or the product, which of course is different from subtraction and multiplication. So let's say we multiply or we subtract one, or we say, let's say 2 minus 3 will not give you a difference that is the same with 3 minus 2. 2 minus 3 is negative 1. 3 minus 2 is 1. So negative 1 is not equal to 1. Okay. So we say that for uh, subtraction, commutative property does not hold. Okay. The same with division. Say 2/3 will give you a quotient that is different from 3/2 because 2/3 is 0.66666 and so on, and 3/2 is 1.5, and these are not equal. So for division, the commutative property does not hold true. It's only for addition and multiplication. Okay, so yeah, that's for commutative property. Now we move on to associative property. A change in the grouping of addends or factors of real numbers does not change the result. So when we talk about associative property, it's the grouping. Okay, so grouping two numbers. Let's say you are adding three different real numbers, adding two, okay, or grouping them does not affect the result. So for example, here we have 7 plus 4 plus 2. So on the left hand side, we group 4 and 2. Now on the right side, we group 7 and 4, but we're adding the same numbers. Okay? Now if you add this, perform 7 plus 4 plus 2 is 6. So 7 plus 6 will give you 13. Now here 7 plus 4 is 11, plus 2 will also give you 13. Okay? And for multiplication, it's the same. 7 times 4, you group 7 and 4 together, times 2. Then we have 7 times the quantity 4 times 2. We have 7 times 4 is 28, times 2 will give you 56. 7 times 4 times 2, 4 times 2 is 8. 7 times 8 will give you 56. So it's basically the same. So in symbols, we say that if A, B, and C are real numbers, then we have A plus the quantity B plus C is equal to the quantity A plus B plus C. Or for multiplication, A times the quantity BC is equal to the quantity AB times C. Okay, that's for associative property. Now we have DPMA, or distributive property of multiplication over addition. When two real numbers have been added and then multiplied by a factor, the result will be the same when each number is multiplied by the factor and the products are then added. So let's illustrate that. Here we are making use of multiplication and addition. So distributive property of multiplication over addition. So here 3 times the quantity 5 plus 8. So when we talk about DPMA here, we just distribute this. 3 times 5, which is this. Then we have the addition sign plus, then 3 times 8. 3 times 8. If you simplify that, 3 times 5 is 15. 3 times 8 is 24. 15 plus 24 will give you 39. So we call this right distributive because the number here is being distributed to the right here. Okay, for left distributive, we have this being distributed to 3 plus 5. So let's try that again. So the quantity 3 plus 5 times 8. So 8 will be distributed here times 3, this one. Then we have the addition sign plus 8 times 5. So, or 5 times 8. So we have 3 times 8 is 24 plus 5 times 8 is 14. If you're going to add that, you will have 64. So in this case, we call this left distributive. So in symbols, if A, B, and C are real numbers, then A times the quantity P plus C is equal to AB plus AC. Or we can say that if the quantity A plus B times C, then this is equal to AC plus BC. That's your right and left distributive. Okay, that's a fourth property, DPMA. And then we also have here the fifth property for real numbers. We have identity properties. For addition, the sum of any real number and zero is the real number itself. Okay, so in this case, the identity number for addition is 0. Okay, in other words, if you add any real number to 0, the resulting number is the number itself. So 55 plus 0 is 55. Okay, 0 plus 3.25 is 3.25. Okay. For addition, our identity number is 1. Okay, for multiplication. For addition, our identity number here is 0. The identity for multiplication is 1. So for multiplication, product of any real number and 1 is the real number. Is the real number itself. Okay. So for example, 65 times 1 is 65. 25.6 times 1 is 125.6. So in symbol, if A is a real number, then A plus 0 is equal to 0 plus A, which is equal to A. And A times 1 is equal to 1 times A, that's equal to A. Note that the identity element for of addition is 0, just like what I mentioned earlier. And that of multiplication is 1. That's for identity. And we also have the zero property. The product of any real number and 0 is 0. Any real number, when multiplied with 0, is 0. So 3/4 times 0 is equal to 0. 1351.14 is equal to 0. Square root of 2 times 0 is 0. Okay, so that's the 0 property. In symbol, if A is a real number, then A times 0 is equal to 0 times A, which is equal to 0. Okay? And now we also have the inverse property. For any non-zero real number, there exists an additive inverse such that their sum is 0 and a multiplicative inverse or reciprocal such that their product is 1. So we can view inverse property as what should be added. For example, here, 18. What should be added to 18 to get the identity element 0? That's for addition. So it is the additive inverse of the number. So the additive inverse of 18 is negative 18. So if you're going to add them, you will get the identity element for addition, which is 0. Same is true with multiplication. So let's say, what should be multiplied to 1/2 to yield the identity element for multiplication, which is 1? So we are going to multiply the multiplicative inverse of the real number. So the given number here is 1/2, and the multiplicative inverse or the reciprocal of 1/2 is 2. So 1/2 times 2 will give you identity element for multiplication, which is 1. So in words, or in other words, if A is a non-zero real number, then A plus the additive inverse. So a plus negative a will give you, or negative a plus a is equal to 0. Okay, and for multiplication, 1 over a times a is equal to a times 1 over a, which is equal to 1. So for inverse property, for addition, the number and its additive inverse will give you 0. For multiplication, the real number times its multiplicative inverse or reciprocal will give you 1. Okay. How are you guys doing? Can you guys catch up? I understand you were able to read this already and probably were able to answer the exercises. So this should be very easy for you now. Okay. So let's see what's next. Okay, so here's what's next. The properties of equality of real numbers. Okay. Equality denoted by the equal sign implies that two quantities are identical. For all real numbers, 5 properties of equality always hold true. Okay, so this is for real numbers. Properties of equality of real numbers. Number 1 is the reflexive property of equality, or the RPE. Okay. For any real number a is equal to a. In other words, for any real number, the number is equal to itself. Okay. 3 is equal to 3, 9 is equal to 9, 1/4 is equal to 1/4, 2 is equal to 2, and so on. We call that reflexive property of equality. And then we also have the symmetric property of equality, or the SPE. For two real numbers a and b, if a is equal to b, then b is equal to a. So example, if 8 is equal to x, then x is also equal to 8. 8. Okay, so say when you are, for example, solving for the value of a certain number, like say x, and your final answer is 2 is equal to x, that is still correct, right? Because basically 2 is equal to x is equal to 2. Okay. All right, that's symmetric property of equality. If a is equal to b, then your b is also equal to a. Transitive property of equality, or the TPE, for any numbers, real numbers, a, b, and c, if a is equal to b, b is equal to c, then a is equal to c. So for example, if 8 is equal to x and x is equal to y, then obviously 8 is equal to y. Okay? So sometimes the transitive property of equality is being used some sort of a problem, especially for linear equations. They would usually use this transitive property of equality to find to have some sort of a problem, and lets you find for the value of x and y, for example. Okay. So here, if 8 is equal to x and x is equal to y, then obviously if x is equal to y, then we know that x is equal to 8, then 8 therefore is equal to y. That's the transitive property of equality. Then we have the addition property of equality, or APE, for any real number a, b, and c. If a is equal to b, then a plus c is equal to b plus c. In other words, if a is equal to b, adding the same number on both sides will not affect a is equal to b. We are actually using the APE when we are solving linear equations. So for example, we have x plus 1 is equal to 3, and you are being asked to solve for x, then x plus 1 is equal to 3. You are going to subtract minus 1 to both sides. Okay, so that's performing the same. Or you're going to add negative 1 to both sides. So you will be left with x is equal to 2. Okay, so we are using the APE in that case. So here, if x is equal to 23, then x plus 2 is equal to 23 plus 2. Okay, so ito yun. If y is equal to 12.5, then x plus negative 4.5 is equal to 12.5 plus negative 4.5. Okay, so here we are just adding or subtracting, adding a number to both sides of the equation. So, diba ganun yung ginagawa natin pag nasusolve tayo? Adding the same number or subtracting or multiplying or dividing the same number on both sides of the equation will give you, will not affect the equation. Diba? Okay. So in our case here, APE yun. Yun yung ibig niya sabihin dito. So multiplication property of equality. So we mentioned this. If 2x is equal to 18, okay? Therefore, 2x times 1/2 is equal to 18 times 1/2. So here we multiplied 1/2 on both sides of the equality sign. That will not affect the equation. Okay, it will not affect because what you did on the left side, you also did on the other side. It's like being fair in life. So anong binigay mo sa kabila, yun din dapat ang ibigay mo sa kabila. Okay? Para ma-maintain yung balance, yung equality. Okay? So parang sa life yan. So once, like if you have, may kapatid ka, once na binigyan mo ng mas mahalaga yung isa and lesser value yung isa, that will cause a problem. Okay? You cannot maintain equality. So, pareho dapat yung halaga nila. Okay? Well, I hope that makes sense. All right. Okay. So, yeah. I think I have to end there. I think we also have properties of negation here. Okay, let's continue. For properties of negation, let A, B, and C be any real numbers. Multiplication by -1. The opposite of a real number A can be obtained by multiplying the real number by -1. So A times -1 will give you the opposite of A, which is -A. Okay, same is true. -A times -1 will give you the opposite of -A, which is A. Okay. The opposite of the product of two numbers is equal to the product of one of the numbers and the opposite of the other. Okay. So here, negative A, the quantity negative AB is equal to A times negative B or negative A times B. First, you already know this. And then product of two opposites, negative A times negative B is equal to AB. The product of opposite of two real numbers is equal to the product of two real numbers. Okay, properties of zero. The product of zero in any real number is zero. So we mentioned that. That's multiplication property of zero. Division property of zero is if zero is divided by any non-zero real number, the result is always zero. So 0 over A or 0 over any other number except 0 is 0. Division by 0 is undefined. We do not define division by 0. So A divided by 0 or A over 0 is undefined. Yeah, I think basically, well, that's it for today's session. So we stop there. Yeah, then we're going to have another one tomorrow. So may I ask you if you guys have questions? Are you guys still there? Parang wala na yata kayo. So where are you guys? Andyan pa ba kayo? Okay, so for further instructions, I'm going to send you some message in your group, in our group chat. Ano? So I will give you some more updates later in our GC. So since you guys have no more question, wala na ba kayong tanong? So if there's none, I think we have to end this live because I'm not supposed to go for more than 30 minutes. All right, anyway, I'm going to do this again. We're going to have this again tomorrow. So if you have your free time tomorrow, I'm just going to send you a message and give you the link for our next lecture series. All right. So since there are no more questions, thanks guys for joining me. Hope you have a great day. Yeah.